Hi everyone, this is lecture video 46 and we will cover trigonometric integrals in this lecture. So trigonometric integrals involve algebraic combinations of 6 basic trigonometric functions like sine x, cosine x, and here you see tangent x, secant x. So we study trigonometric integrals into these two main cases, and if we concentrate on this type of integrals where you try to integrate products of sine and cosine of any powers, we can divide this case also into subcases. So let's first concentrate on the case where at least one of the powers, these powers m and n, is odd, okay? So at least one of the powers m or n is odd. So let's try to understand what happens in this case. So let me emphasize this case like doing this. Okay, what happens in this case? Let's say if m is odd. You see, m is the power of the sine function. Then we will use a substitution to handle this integral. Okay, of course, in both cases, we will be using a substitution to evaluate the integral, and we are covering now which substitution will work for each case. So if m is odd, where m being the power of the sine function, then you will use this substitution. You will choose u as the function which has non-odd power, okay? In this case, it is cosine. So you first decide if at least one of the powers is odd, you look at the function having the odd power and you choose the other one as your substitution. And using a substitution means what? You try to rewrite the whole integral in terms of u's and du's. It will be possible if you choose u equals cosine x substitution in this case. Then you will try to integrate the integral that you obtain in terms of u's and du's only. Okay, then what if n is odd? So thinking like the similar as in the previous case, we will use the substitution u equals sine x. So if the power of cosine n is odd, then your substitution will be the non-odd power, like u equals sine x in this case, okay? It will definitely work. So if both of the powers are odd, so let's also cover that case. If both powers, both n and m is odd, then both substitution will work, okay? Then you can either use cosine x as your substitution or use sine x as your substitution, and you can be sure that both substitution will work. Okay, and I think there is one more case that is not covered in this list. So we covered the case where m is odd, n is odd, or both of them is odd. What if none of the powers is odd? Meaning that we are trying to understand the case. What if both powers are even? If both m and n are even, then we will use another way to handle the integral. We will first use half angle formulas. What are they? So we have these formulas for sine square x and cosine square x. Okay, let me write them down. Sine square x and cosine square x are given by these half angle formulas. And they look almost the same except this plus minus difference. So if both powers are odd, for example, if you have sine square x times cosine square x dx inside your integral, first thing to do is to put these half angle formulas, then you start computing the integral, okay? So that's the summary of what you should do when you have an integral of this type, products of sines and cosines. Okay, let's look at the first example. As you can see here, we have one of the powers is odd. So the power of sine m is 3, which is the power of sine x. It is an odd power. That's why we use the substitution u equals, so non-odd function will be used as the substitution as I write here, u equals sine x. Then what is du? du is minus sine x dx, and it is possible to rewrite your integral in terms of this substitution, right? So how do we rewrite it? Sine cubed x cosine square x dx is written like this, sine square x. So you see, sine x dx, this part will be serving as our minus du. That's why I will just separate one of the sine function from here, and I will write it near dx. That's why for this part now, I express it as minus du. And there was this part also here, cosine square x. Okay, what is cosine square of x is in our new variable u, it is u square. And now we should find a way to express sine square in terms of cosine so that we can use our substitution u also for this part. So obviously it is 1 minus cosine square x, and this is 1 minus u square. You see, I transform everything to u's and du's in this way. So the integral is 1 minus u square, this part, times u square times minus du. So I put minus here and times du. Okay, then this is a simple integral to handle. You know, after you do this multiplication, you can easily evaluate the integral. This is the integral of u square minus u to the power 4 du, and then integrate it. So minus, what is the integral of u square? It is u cube over 3. You add 1 to the power, you divide by the same power. So u to the power 5 over 5, and then plus c, of course, don't forget to put this arbitrary constant c because you are dealing with an indefinite integral. And then the last step will be, you will turn back to your original variable, okay? So what I mean is, instead of u, you should write, remember what u was. U was cosine x, so you will do a back substitution here. Cosine x, so there was this power 3 here, 5 here. After doing the back substitution, then you are done. This is your final result. Don't forget to turn back to your original variable x like this. Okay, that's how you handle. So what we do, we first determine the odd power. It is the power of sine function, and then you need to choose the other function as your substitution. And also somewhere on the way here, right here, we use this trigonometric identity. Let's also put it down here. So in integrals of the products of sine and cosine, you are always using this. You will always be using this trigonometric identity too, other than your substitution. Okay, let's move on to the next example. Cosine to the power 5. There is an odd power here. Okay, it is the power of cosine function. Then, which substitution we will use? the other function will be used as the substitution. Even if you don't see any sine x's around, you can use it as your substitution. It will work, you will see. Because how do I decide to choose this substitution? I look at the odd power, I use the other function as the substitution. So du then is cosine x dx. Then the integral can be rewritten as, okay, let's see what we can do. Okay, so cosine x dx, I need this expression to serve as du. That's why I will take one cosine. I will separate one of the cosines like this, and 4 of them is still here. And I can write that cosine to the power 4 as the square of cosine square, right? Okay, then this part is exactly du, and this part, I need to search for a way to write this part in terms of sine x. And it is possible by using this trigonometric identity again. Because cosine square x is 1 minus sine square x. Okay, let's write this down. 1 minus sine square x. Don't forget to put this square power also. And this part is then 1 minus sine x is your u, like this. You see, we write everything in terms of u's and du's here so that this substitution works. Du. Okay, compute this square, please. It is 1 minus 2u square plus u to the power 4 du, and then you start evaluating the integrals. Integral of 1 is u. Integral of u square is u cube over 3. Integral of u to the power 4 is u to the power 5 over 5, plus an arbitrary constant c, of course. And for the last thing, you need to do your back substitution. You need to turn back to your original variable x. Okay, so I will write what was the substitution. This was our first line, first substitution. I will write sine x for all the u's in this expression. So sine x, sine x, sine x. So back substitution. Okay, this is your result. Let's look at this case. Here, as you can see, both powers are odd. So m is 3, n is 3, both are odd. That's why any substitution can work here. Remember our diagram? So if both of the powers are odd, either u equals cosine x or u equals sine x, both substitution will work. Okay, so then you can choose any of them. I will choose u equals sine x for our substitution, and then du is cosine x dx. Then let's rewrite our function in terms of this new variable. Cosine x dx, just separate one of the cosine x to be, and to write it in terms of du, and what is left here, cosine square x and sine cube x. So let's start converting everything to u's and du's. This is du, and this part is u cube, and you know how to transform cosine square x to sine square x to use your substitution, right? It is 1 minus sine square x. That's why this part also is written as 1 minus u square. So that's your integral. U cube 1 minus u squared du. Okay, do this multiplication first. But you have u cube minus u to the power 5 du, and then integrate. It is u to the power 4 over 4 minus u to the power 6 over 6 plus an arbitrary constant, because it is an indefinite integral. And the final result, you need to turn back to your original variable x. Okay, u was sine x, just put sine x instead of u. Okay, this is your final result. And here in this example, you see an example where both powers are even, okay? So here m is 2 and is 2, both are even. Remember what we should do for this case? Let me remind you from our diagram. If both powers are even, you first insert this half angle formulas, okay? Let's do that. Okay, then what we have, I can take this 16 out because it is a constant. Sine square is 1 minus cosine 2x over 2. Cosine square is 1 plus cosine 2x over 2. Okay, let's write those half angle formulas here also. Sorry, this is cosine 2x. Okay, and cosine square x is written like this. I inserted these formulas for sine square and cosine square x. Then I will do this multiplication. Okay, so let's multiply. Then you have what? 2 times 2 is 4, so I take it out. It is in the form like 1 minus a, 1 plus a, so you can easily multiply it as, okay, maybe I should do a very quick recall here. If you have such a multiplication, a minus b, a plus b, it is multiplied as a square minus b square. Remember? Okay, so that's what we have here. A is 1, b is cosine 2x, so a square minus b square dx, and 2 times 2 is here as 1 over 4 in front of the integral. Okay, and now what we should do is start integrating. So 4 times integral of 1 is x. Then what is the integral of this part? We need to deal with it now. And again, you see, you have a power which is even. That's why you insert this formula again. You will insert the half angle formula again for this function. So it goes like 1 minus cosine double this angle. Remember the formula, if the angle is x here, you write 2x on the right hand side, you double your angle. That's why I will be writing 4x over 2, okay? And like this. Then we need to integrate this, okay? 1 over 2, you can take it out. Then integral of 1 is what? It is x. Integral of cosine 4x is what? It is sine 4x over 4. Then, okay, let's do it like that. Then at the end, you can insert your arbitrary constant c. Maybe here I can put a very small recall for you about the integral of cosine kx's or sine kx forms. Cosine kx dx is sine kx over k, and similarly, sine kx dx, where k is a constant, is minus cosine x over k. Of course, these are arbitrary constants. Okay, that's what you should do if both powers are even. You will insert these half angle formulas. This is the only way to evaluate your integral. Okay, finally, I will write a few comments on this question and then leave the rest as an exercise to you, and I will stop. What do you see here? This is sine square x, cosine to the power 4. And as you noticed, both powers are even. That's why you will be inserting half angle formulas again. So you already have sine square, and you can write the second component second function as the square of cosine square. That's why now you are ready to insert your half angle formulas. And for this cosine square here, you will write cosine 2x over 2. But don't forget to put this square, okay? Inside your integral, you have this. And then after evaluating this square, you first evaluate it. Then you will try to handle this multiplication. First this, then this multiplication. You do those computations, and then you will start evaluating the functions appearing after the computation, okay? So I stop here. Thank you for your attention.